Let's talk about this warm-up. Guys, the first one was in what form? Y equals mx plus b. What's the name of the form, though? Slope-intercept. So, from this equation, we should get two things. We should get the slope and the y-intercept. Mia, what's the slope of this line? It's 3. M equals 3. Alfonso, what's the y-intercept?
4.
No.
No, the y. Oh, for the bottom one?
What?
For the bottom?
No. That first equation. I want the y-intercept. You said 4. You're close, but not right.
Negative 4.
It's -4, okay? Your y-intercept is -4. That means I need to start my graph at what point? -4. 0, -4. Do you guys agree? So 0, -4 is down there. And my slope was what?
3.
3 over 1, right? So I move up 3 and then where?
To the right one.
To the right 1. So if you go up 3 and to the right 1, your next point is 1, -1. Go up 3 again, 1, 2, 3, to the right 1, and you have 2, 2. Then draw a line extending through those 2 or 3 points. Any questions on the first line and the first equation? I want you to label your line with the equation. This one was y equals 3x minus 4. Put it right next to the line, because we're going to use this in a second. Okay, the black line, the equation was 4y plus 2x equals 12. How do we go about graphing that? Miss Gagne?
First, we change it to slope-intercept form.
Okay, a lot of students did that. You can absolutely do that. How did you change it?
First, I subtracted 2x on both sides, so it is 4y equals -2x plus 12. So simplify that.
Good.
Now I simplified, and it's divided by 4 on the left side and divided by 4 on the right side.
Uh-huh.
I got as the answer was y equals -half x plus 3.
Very good. Y equals -1/2 x plus 3. Graphing that, Mia, what's the slope of this line? It's -1/2. And Alfonso, what's the y-intercept? It's +3. Very good. Okay. That means we're starting at what point, Alfonso? 3 on the y-axis. And how are we moving, Mia?
1 up to the right.
No. It was, what was the slope again?
Oh, negative, so,
Ah.
so 1 down to the right.
Very good. 1 down and then 2 to the right. That's how we get this line. Do we see it? Are there questions? Now, there's an easier way. I personally feel like there's an easier way to do the second one. And it's by recognizing what form it's in. What form was the second one in? Standard form. Do you guys remember what's the advantage of standard form? The x and the y-intercept. So I want you to write both methods, please. Okay, over here on the left, we find an x-intercept by doing what? Making y equal to 0. And we find a y-intercept by making x equal to 0. Put a squiggly down the middle. If I make y equal to 0, so in other words, eliminate the 4y, what's my new equation? 2x equals 12. And solve for x. What would you do? Divide by 2. X equals 6. Look at the black graph that you drew, or whatever color you used. Does it go through the point 6, 0? Huh. Interesting. Okay. Then do it for the y-intercept. Make x equal to 0. What's my equation? 4y equals 12. The x term is gone. You divide both sides by 4, and you get y equals +3. Okay? So now my y-intercept is 0, 3, and that we already knew by changing it into y-intercept form, or slope-intercept form. Are there any questions? But my biggest thing is like, does it matter which way you do it? And the answer is no. You can use whatever method you feel most comfortable using, okay? But just make sure if it's in standard form, you have the option, because you can graph it any way that you want by just using the x and the y-intercepts. Questions on graphing them? Okay, I want to do a little exercise with you guys. Please, if I write anything down, please write it down as well, okay? I do want you to label this line. What was the original equation? Someone pull it up for the second. What was the second equation? It was like 4x.
4y plus 2x
4y plus 2x equals 12, okay? I want us, use a different color for this part. Pick a point on the black line that we have not already listed. Pick a point on the black line that we have not already listed. Natalie? 4, 1. I love it. Put a point there and label that point 4, 1. Now, the whole idea behind this line says that if we pick any point on that black line, it should work when we plug it into the equation. Do you guys agree? So if I take 4, 1 and I make x 4 and I make y 1, because coordinates are x's and y's, and I plug it into my equation, it should work. It should give me something that's true. Let's test it. So plug in x as 4 and y as 1. We're going to get 4 times what? 1 plus 2 times 4 should equal 12. Are you guys cool with that? I'm just plugging in 4, 1. What's 1 times 4? And what's 2 times 4?
8.
Is 4 plus 8 going to give me 12?
Yes.
Good. So now we know 4, 1, it is a point on that line, on that black line. Okay, let's do the same thing, but let's do it for the red equation, which was y equals 3x minus 4. Give me another point on the red equation. McCarvin? 1, -1. I love it. Write that down. 1, -1. So I'm going to use 1, -1, and I'm going to plug it into y equals 3x minus 4. I'm going to do it over here. 1, -1 into y equals 3x minus 4. What do I do if I'm going to test this? What do I do? Plug in. How do I plug in the coordinate? You're right, Austin.
Put x for 1 and then y for a minus 1.
Good. X equals 1, y equals -1. Now, guys, I want to stress this. How did Austin know that x was 1 and not -1? How did he know that he's plugging in for 1 and not -1? Natalie?
Because when you have like the parentheses, x is always first.
Very good. It's always x, y. Excellent. Okay? All right. So we're plugging in 1 and -1. What do we get? What do I get when I plug in 1 and -1? What's my new equation? Gabriel, what's my new equation?
-1 equals 3 parentheses 1 minus 4.
Good. Christian, what do I do?
Multiply the 3 and the 1.
Good. Which is?
3.
You're good? Now what? Yeah.
Wait. So ain't the -1 replace the -4?
Nope. Mm-mm. What do I do from here? McCarvin?
You just like finish the equation.
Mm-hmm. So what do I get? Equals? -1. Did it work? Sure it did. Now it makes sense because we picked a point that was on my line. Do you guys agree? So zoom out and look back at the graph. So 4, 1 worked for the black line. Do you guys agree? And 1, -1 worked for the red line. They won't work for each other unless you're at the point of intersection. Where do those two lines meet up? Natalie? 2, 2. 2, 2. Guess what's so important about 2, 2? It's the only point on in the entire coordinate system that will work for both of those equations. It's the only point in the entire coordinate plane that will work for both of those equations. Okay? Because it's the intersection. Do you see how it's a point for both the red and the black line? Okay? Now, just so we are completely on the same page, what if I picked -2, comma, +2? Will that point work for the black line?
Yes.
It will?
No.
It will not. Why will it not work for the black line?
It's not on the line.
It's not on the line. Will it work for the red line? No. So 1, -1 worked for the red line because it was worked for the red equation because it was on the red line. Do you guys agree? This one worked for the black line because it was on the black line. It was part of the black equation. This point is the only one that will work for both. And that is what we call the solution. So highlight it, okay? This is what we're learning today, okay? Is that in a system of equations, in other words, more than one equation, there's exactly one point where it'll satisfy both equations. And there's no other point where that'll happen. Okay? Let's start by talking about what a system of equations is. Okay? So a system of linear equations is a set of 2 or more linear equations. Okay? So it cannot just be one equation. It has to be 2 or more. Okay? Now, it also has to have the same variables. And 99 times out of 100, what are our variables going to be? X and Y. Okay? So it cannot involve x, y, and z in one equation and just x and y in the other. They have to have the same variables, okay? Now, another example of a system of equations is given down below. It's a system of equations because how many equations do I have? 2. And what are the variables in each of them?
X, Y.
X and y, okay? So as long as they involve the same variables and there's more than one equation, it's a system of equations, okay? Now, the solution to a system of equations, this is a little bit different, okay? When we think of the word solution, right? You guys probably think of like, oh, x equals 6, right? That's a solution, right? When we're talking about the solution of a system, just like we talked about in the warm-up, it's actually a point, right? And a point has how many components? 2. An x value and a y value. So whenever we're talking about a solution, we're not talking about a single number. We are talking about an ordered pair, okay? So an x value and a y value, okay? Whenever it's a system of equations. All right, so in the first set of examples, we're just checking whether points are solutions to the equations, to the system of equations, okay? So take a look at the first one. How many equations do I have in the first system? 2. They both involve x and y. Do you guys agree? And what we're testing is we're going to say, okay, is 2 comma 5, is that the point where both of the equations meet? And how we test this is we just plug it in to both equations. Now, it has to work for not just one, but both equations. Okay? So, if I have the point 2 comma 5, what am I substituting in? I'm substituting 2 for what?
X.
X. And I'm substituting 5 for what?
Y.
Y equals 5. So now take each of the equations and make those substitutions. So we're going to get x plus 7 equals y. X is now going to become 2. And y is going to become 5. Does 2 plus 5 equal 7? 7 equals 7. It works for the first one. So that means that if we were to graph x plus y equals 7, okay, this point, 2 comma 5, would lie on our graph. But we also have to check the second one. Is it the solution? Is it the point where the two lines intersect? So check it for the second one. We're still plugging in x is 2 and y is 5. This is going to be 2 times 2 minus 3 times 5 equals negative 11. Do you guys see I'm just substituting 2 for x and 5 for y? Is that clear? Okay. By order of operations, what do I need to do next? By the order of operations, what do I need to do next? Juliana? Good, multiply. So, what's 2 times 2, Gabriel?
4.
And 3 times 5? 15. But this is going to be adding or subtracting, and why? Subtracting, because it's negative 3 times positive 5. Do you guys agree? What's a negative times a positive? Negative. So 4 minus 15 equals negative 11. Miss Alonzo, what is 4 minus 15? It's negative 11 equals negative 11. Did it work for this equation? Bingo. So is this the solution of the equation? It's the solution of the system, okay? Because it worked for both of them. So what we would write is we would say 2 comma 5 is the solution. So, in B, okay, we're going to do the same thing. What am I plugging in for x? Negative 2. X is going to be equal to negative 2. And y is going to be equal to 0. Plug it into the first one. What do I get? Emma, what do I get?
Negative 2 times negative 2 minus negative 4 times 0.
Wait. Remember, it's y equals. So let's start. What are we plugging in for y again? 0. So it should be 0 equals, then it's negative 2 times negative 2, and then minus 4. Okay, Emma, what's negative 2 times negative 2? Positive 4 minus 4, and 4 minus 4?
0.
So we have 0 equals 0. Did it work for this equation, Emma?
Yes.
Beautiful. Okay. AJ, when you plug it into the second one, what do you get?
0 equals negative 2 plus 4.
Colin, what's negative 2 plus 4?
2.
Did it satisfy this equation? Okay. So check this out. This point, it's going to lie on the first line, but will it lie on the second line? So is it the solution of the system? And the answer is no, okay? It's not the solution of the system. Why not? Why not? How did you know that this one wasn't, but the first one was? Karen?
We can't intersect both lines.
Very good. This point does not intersect. It's not the intersection of both lines. Very good. I want you guys to try C and D right now. Go. Okay. You should have gotten that C was not the solution and D was the solution. Check, talk, and go. All right. So for the first one, for C, who got it right? You can walk me through it. Go ahead, Addison.
I did x equals 1 and y equals negative 2.
Uh-huh.
And then for the first equation, I did 2 times 1 plus negative 2 equals 0. And then 2 plus negative 2 equals 0. 0 equals 0.
So it worked?
Yes.
Perfect.
And then for the second one, I did negative 1 plus negative 4 equals 5.
Whoa, how'd you get plus negative 4?
Because 2 times negative 2 equals
Yep.
negative 4.
There we go.
Negative 1 plus negative 4 equals 5. And negative 5.
Negative 5 equals 5?
Yes, which is not
It's not what?
the solution.
It's not true. Okay? So then this is not the solution. Very good, Addison. Any questions for Addison on that first one? How many of us got it right before we went over it? Okay, good. Did anyone get the second one and can walk me through it? Go ahead, Natalie.
Okay, so first, the x was 1,
Mm-hmm.
And for the first equation, I have taken for y, 4 equals 3 times 1 plus 1. And then I multiply 3 times 1 is 3. And 3 plus 1 is 4. So 4 equals 4. That's correct.
Good.
The second equation I put in for y is 4. So 4 equals negative 1 plus 5. And that equals 4. So 4 equals 4.
Very good. So if it works for both, what can we say?
That's a solution.
Yes, it's a solution. How'd we do? How do we feel so far? Okay. If it doesn't work for either equation, right? It's a point that doesn't lie on either of the lines. Is it a solution? No. Okay. And if it works for one and not the other, it's not a solution. Okay. All right. Moving on. Now we are going to be tasked with graphing them and figuring out, okay, what is the point of intersection? In these examples, please read the steps. Step number 1 says we have to graph each of the equations in the system. And they have to be in the same coordinate plane. They have to be on the same graph. That way we can see where they intersect. Then you have to estimate the point of intersection. Notice how it says estimate. Is it possible that you pick the wrong point of intersection? Yeah, that's very possible, okay? What if your graph wasn't a perfectly straight line? It's going to be hard to tell. Do you guys agree? So to make sure that you pick the right point, what do you think you do after step number 2?
Do some equation thing.
You check it, right? So do you see what we just did in the last few problems? We took that point and we tested it in both equations. You have to check as step number 3, okay? Start it. If you don't check in step number 3, you could potentially get the question wrong. And why would you get a question wrong when you can check and make sure that you're getting it right? That way you go into it, you're like, I know for a fact this is the answer. It has to be because I checked it. Okay? All right, so let's do it. So we are going to solve the system of linear equations by graphing them, okay? So let's start by graphing the first one. I'm going to use green and red as my colors because #Christmas, okay? All right, look at the first one. We've got y equals negative 2x plus 5. How do I graph that? Kyra, how do I graph it?
So your slope is negative 2.
Uh-huh.
And then your y is 5.
Good. What does that mean? My y is 5.
That's your y-intercept.
Excellent. So I'm going to put a point at what point?
5.
Yep.
And then,
5 on the y-axis, so 0, 5. And then what?
and then you go down negative 2.
Mhm.
And then you go to the right one.
Perfect, because that's my slope. Down 2 and the right 1. Guys, draw a line that is very, very long. The reason it needs to be long is because you need to be able to tell where the other line is going to intersect it, okay? So draw it for a large distance in both directions. Okay. And then I said for the second one, I'm going to use red. Someone else following Kyra's footsteps. She did a great job with the green one. Someone graph the red one for me. Walk me through it. AJ, go for it.
So you put your first point at, the slope is 4,
My slope is 4.
and the y-intercept is negative 1.
Good.
So you put your first point at 0, negative 1.
Perfect. 0, -1 is my first point. Yep.
And then you go up 4 to the right one for your psyche, and you do that again.
And then I do it again. So 2, 7 and 1, 3. Draw for a large distance in both directions. Okay. Can someone give me an approximation for the value or the coordinate where these two lines intersect? Salucci. Very good. At 1, 3. If we stop here, is it appropriate to say 1, 3 is my answer?
I mean, yeah, but you have to check
No.
it.
What if you graphed it wrong? What if the line that you drew was just slightly squiggly, okay? In order to make sure that it's the answer, what do I need to do? Yes. Good, Andrea. Plug it back into both equations. Andrea, walk me through plugging it into the green one.
So you plug in 1 to s and then 3 into y.
Mm-hmm.
And then you get 3 equals 3.
3 equals, well, it's going to be -2 times what?
Oh,
1 and then plus 5. Excellent. And then you said it's 3 equals -2 plus 5. So 3 equals 3. You are correct. So it works for the first one. Are we all cool with that? Seb, can you walk me through plugging it into the second one?
So you put 3 in y,
Mm-hmm.
and 3 equals 4 minus 1, and 3 equals 3.
Good. Because it's technically 4 times 1, right? Which is just 4. So it's 3 equals 4 minus 1. So 3 equals 3. So now we are 1,000% confident that this is the solution. We can stop here. 1, 3 is the intersection point. We know that because we checked it. Preguntas, questions. Yeah, Gabriel.
How would we write our answer on the test?
You would just circle 1, 3. That's your solution.
So
Okay?
we don't put yes, comma, solution?
Nope. That's only if you're checking it. Because it already gives you the point. It's asking you whether it's a solution or not. This one was just asking us to solve, right? And we solved it by finding the solution, which was 1 point. Yeah.
How many points would we need minimum?
How many points would we need minimum? Well, let's think about it. 2 lines that intersect, they're going to intersect at how many points? 1. So how many solutions do I have to this system?
2. 1.
2.
Oh.
1. Do you guys agree with that? These 2 graphs, is there another point where the green graph is going to cross the red one? No, it only happens at that point. Do you guys agree? Now, hypothetically, I'm going to work off of Christian's question. Let's say both of our lines looked like this. Do these lines ever intersect?
No.
Why not?
Because they're parallel.
They're parallel. So, does this system of equations have a solution?
No.
The answer is no. There's no solution here. Okay? So you have to look for these examples. If they're parallel, there's going to be no solution. And what if they had the same slope and the same y-intercept? In other words, they were the same line. They were completely overlapping. How many solutions would I have then? Infinitely many. Okay? Good question. All right, moving on. B. Let's do it. Alex, did you have a question? Example, okay? Yes, the solution was 1, 3. Okay? This was a separate example. Okay, I put a star next to it. The no solution one was just so we could see 2 parallel lines. Okay? Completely unrelated to our last problem. All right, let's do B. So we've got y equals x minus 2 and y equals -x plus 4. Alfred, graph the first one, please.
Our M is 1,
Good.
and then our B is -2.
Excellent. What do I do?
And then you put it on -2
Where?
On the graph,
Where? Here or here?
y.
Good. Okay.
And then up 1 and to the right 1.
Beautiful. McCarvin, do the red one, please.
Your M is -1,
Okay.
and your B is 4.
B is 4. What does that mean? How do I graph it?
You graph 0, 4,
Mm-hmm.
and then you go down 1 and to the right 1.
Good. Anyone want to be bold and try to approximate the intersection point? Austin?
3, 1.
3, 1. Casey, are we 1,000% positive that's where it intersects? Not until we do what? Check it. Okay. So, Juliana, walk me through checking the first one.
Do one.
Uh-huh.
1 equals 3 minus 2.
Good. And?
And then 3 is 1.
So 1 equals 1. Did it work?
Yes.
Perfect.
And then 1 equals -3 plus 4.
Mm-hmm.
And then it's always 1.
Perfect. Casey, are we now 1,000% sure that this is the correct point?
Yes.
Why?
Because we checked.
We checked it. Okay? And it worked for both of them. Now, hypothetically speaking, guys, Kirsten, what if it didn't work for one of my equations? It wouldn't be a solution. But remember, just by looking at this graph, do you agree we should have a solution? Because these two lines are not parallel. So either we graphed it wrong, okay, or we plugged it into our equation wrong. You have to figure out where you messed up, okay? I personally would bet money that it's probably the graph, okay? And you should go back and re-graph it, okay? Double check that your slope was correct. Double check that your y-intercept was correct. Yeah, Gabriel.
So the only time that it wouldn't be a solution is if we graphed it wrong?
Potentially. Or I have seen where students get it wrong. Like they say that it's not a solution because they're like adding these wrong. They get like -1 here. They're like 1 equals -1. Oh, it doesn't work. But remember, check your arithmetic, check your algebra, and check that your graph was correct, okay? One of those two is off. Got it? Okay, I want you guys to try C and D. Go. I want you guys to check what you got with what's on the board. And I would like you guys to discuss for a full minute to try to help each other out to get those answers. Go. First one, you should have had a y-intercept of 3. And then you should have gone up 1 to the right 2. So it should have looked like this and like this. And then for the second one, it should have had a y-intercept of -5. And we're going up 3 to the left 2. 1, 2, 3 to the left 2. Up 1, 2, 3 to the left 2. Oh, whoops. Up 1, 2, 3 to the left 2. There we go. You would have found that they're intersecting at this point right here if you continued this line. And this point is -4, 1. And when you checked it, it should have worked. How many people got this one?
Why couldn't you go down 3 to the right 2?
You could go down 3 to the right 2, but then you're kind of moving in the wrong direction, right? But still, at the same time, even if you go down 3 to the right 2, do you see how it's still part of the same line? So you'd have to continue it the other way as well.
Well, why does we go that way instead of that?
Okay, so then when we plug in -4 and 1, let's see what we get. So for the first one, when we're plugging it into the red equation, that was the first one, we would get 1 equals 1/2 times -4 plus 3. Remember, -4 times 1/2 is going to give you 1 equals -4/2 plus 3. Because remember, this -4 is technically -4/1. We multiply fractions straight across. So -4 gets multiplied by 1. And the 2 gets multiplied by 1. So now we have -4/2, which is just -2, plus 3 equals 1. 3 minus 2, or -2 plus 3, is also 1, so 1 equals 1. It works for that one. The second one, we have to do the same thing, so plug it in to the green one. We're going to get 1 equals, and it's -3/2 times -4. And then -5. So -4 times -3/2. 1 equals a +12/2 minus 5. This is going to be 1 equals 12 divided by 2 is 6. 6 minus 5 is 1. So 1 equals 1. We're Gucci. Okay? So as long as we plugged it back in and checked, we're good. And remember, the answer to D is 2, 1. The two questions at the bottom, why do you have to check your answers in both equations? Because if it's a solution of the system, it has to work for both equations. And the second question, should we trust that just looking at the graph will be the answer? And the answer is no. You only approximate by looking at the graph. We need to check afterwards. Okay? We always need to check because looking at the graph is just an approximation. If you want to be 100% sure, you have to check that answer.